Hi folks, this is AAT section 2.1 Graphing Quadratics in Vertex Form. So linear functions is what we have been looking at a lot, things in the form ax plus by equals c are used throughout math and science due to their simplicity and applicability. But quadratic functions comprise another very important category of functions that are also used a lot in math. Quadratic function is a function in the form ax squared plus bx plus c. So notice you have a square term, and then what's called a linear term, and then a constant term. And a, b, and c are integers, but a should not be 0. A cannot be equal to 0. Graphs of a quadratic function for shapes have shapes called parabolas. And you've seen a parabola before. It looks like this or like this. It's going to face up if your a value is positive, and face down if your a value is less than 0, negative. So here we're going to start out graphing a simple basic parabola. This is called our parent graph or a parent function because it's just as basic as you can get of a quadratic function before it's moved up and down, left and right. So we're just going to plug in points for x here. If we square 0, we get 0. Square 1, we get 1, 1, 4, and 4. And then we're going to plot these points, and we're going to see 1, 2, 1, 2, 3, 4. It's a symmetric graph. This one has its vertex at 0, 0, and there's your nice parabola. Now notice, and you've probably seen this before, how parabolas move. They don't move with a constant slope. If from the vertex, whatever your a value is the number in front of your squared term, so here it's 1. If from the vertex you go over 1, you're going to go up a in both directions. So instead of plotting the points, we could have just gone over 1, up 1. And if we go over 2, we're going to go up 4 times a. Remember, a was 1, so that would be 4. So from the vertex over 2, we're going to go up 4 to get another point on either side. If we go over 3 from the vertex, we're going to go up 9 times a, which would be 9 times 1 is 9. So our next point would be 1, 2, 3, up 9. So our next point would be here and over here if we continued that parabola on. So notice these are going up by squaring these terms. This is 2 squared, 3 squared. So if we kept going, this would be 16 times a, and so forth. Nice, easy way to put the parabolas on a graph. Okay, describe in words how the following parabolas would differ from the graphs above. So adding or subtracting or multiplying numbers to your original parent functions are going to shift them. Here we're adding to what was y. So this is a shift up or down. This is going to be shifted down too because it's negative. Inside the parentheses, this is a shift to your x. Here our vertex is now going to be shifted over 2, and it's going to kind of go the opposite direction of what you think it's going to go. 1, 2 would be the vertex, would be over 2. The parabola would be in this area. So shift right 2. Remember to use the opposite sign of what you see if it's in the parentheses. If you're multiplying by a number, this is going to be a stretch. You're going to stretch this parabola because think of your a value. Instead of going over 1, up 1, like we said in that parent graph, you're going to go over 1, up 1, 2, 3. So those second points are going to be a steeper part, making this whole graph narrower. So the graph's going to narrow if this a value is greater than 1 or less than negative 1. But here, the negative is going to flip the whole graph across the x-axis. And an A value of 1/2 is going to make it wider. It should make sense. So if we think of where the parent graph was, now the whole thing's going to flip, but instead of over 1 up 1, we're going to go over 1 up 1/2. So if this is 1, 2, 3. So we're not going to go, if we go over 1, we're only going to go 1/2. So it's going to be a wider graph than it was before, because our A value is less than 1. It's between 0 and 1. Okay, moving to the next page. So here's kind of a depth of just all the directions of what can happen. Vertical shifts C units up when you are, notice right here, when you're adding something to x squared, it's going to shift it up. If you're subtracting something to x squared, it's going to shift it down. If you're subtracting inside the parentheses, it's going to shift it right. If you're adding inside the parentheses, it's going to shift it left. If you change the sign in front of the x squared, it's going to flip it across the x-axis. If you change the sign inside the parentheses, it flips it across the y-axis, which if you flip this parabola across the y-axis, it's going to be the same place it was before. If this value in front of x squared is a C value that it's greater than 1, or if C is less than -1, it's going to get narrower, thinner. And if you've got a little fraction for that A value, here it's a C value, it's going to make it wider. Okay, so vertex form is this, AX minus h squared plus k, where the vertex of the parabola is h and k. Notice the h is going to be the opposite sign. You might want to write yourself a little note. But the k is going to be the same sign. And then we're going to use the over and up to graph it after that. A tells you whether it opens up or down and how narrow it is. Okay, so graph each of the following, label the vertex. So our vertex here is 1, -3, opposite sign of 1, same sign as -3, and our A value is 2. So we're going to start at 1, 1, 2, 3, -3, and we're going to go over and up, over 1 up A, over 2 up 4 times A. A is 2. So over 1 up 2, over 2 up 4 times 2, which would be 8. From the vertex, over 1 up 2, over 2 up 8. 1, 2, 3, 4, 5, 6, 7, 8. And there's that one. Okay, pause right here and try the next one. Notice, be careful, it flips upside down because it has that negative in front of it, and then turn it back on to check your answer. Okay, so here's the answer to the next one. The vertex was the opposite sign, -2, 4. Your A value was -3, so you went to -2, 4, over 1, down 3, over 2, down 4 times A. 4 times 3 would be down 12 to give you that parabola. Pause a second and figure out what you did wrong if you didn't do something totally correct. Okay, so flipping on over, so this is going the other direction. We're trying to find the equation of the graph. So we're trying to get it into y equals A times x minus h squared plus k. So first thing we want to find is that vertex. Looks like that's at 2, 1, 2, 3, 4, 5, 6, 7, 8, 2, -8. So the 2 goes in as the opposite sign. The 8 stays the same sign. And then we got to find our A value. And I can see I'm going over 1 up 1. So my A value must just be 1, so I don't have to actually write a 1 in as the leading coefficient. There's my equation. Okay, next one. 1, 2, 3, 4, 5, 6. Vertex looks to be 0, 6. So we have x minus 0 squared plus 6. And our A value, if I go over 1, I can't tell how many have gone down. It looks to be a fraction. So look and find the first point that you can tell is a real point crossing where it should. And it looks like this one right here would be a good one. So I've gone over 2, down 1. So if I've gone over 2, I'm supposed to go up or down 4a. So 4a here is equal to 1. I am going up or down 1. So if 4a equals 1, I just solved this little equation. My a value must be 1/4, but since it's going down, it's negative 1/4. So we clean that up a little. We don't have to, of course, have x minus 0, so it's y equals 1/4 x squared plus 6. Okay, the axis of symmetry is the line that goes through the middle of the parabola, cutting it in half. And since these parabolas all have vertices, their x values will be where that axis of symmetry is. So for instance, this one has an axis of symmetry at x equals 2, because this line has an equation of x equals 2. So go ahead and graph both of these, and then we will check them to make sure we've found them and their axis. Okay, so here are these. For the first one, the vertex was -3, opposite sign, -1. So I went to -3, -1. Our a value was 1/2. And so if I went over and up, over 1 up a, which is 1/2, over 2 up 4 times a, and 4 times 1/2 is 2. So I didn't use that first point because it's just a fraction. So let's use the second point. Over 2 up 4 times 1/2, which would be up 2, and that's what those 2 points are for those second points. The y-intercept is 0, 7/2. You find a y-intercept by plugging in 0 for x. The y-intercept is where x equals 0. So if I plug in 0 for x, and I did it right here, 1/2, 0 plus 3 squared minus 1. Pause it if you need to see how I got 7/2. So the y-intercept is 0, 7/2, which looks to be right. The axis of symmetry is x equals where that x value is. This is the axis of symmetry, x equals -3. On the second one, the vertex, you don't have parentheses, so the vertex is just 0 in there, what's being subtracted from x. 0, 3 is the vertex, so we start there. My a value is -2/3. Okay, so let's look at that one. If we go over and up, over 1 up a, don't want to graph -2/3. Over 2 up 4 times a, that's still -8/3. Ugh. Over 3 up 9 times a. So I'm going to just keep going until I get a nice number. And 9 times 2/3, 3 will go into 9 3 times, is -6. So that's the number I'm going to use. So over 1, 2, 3, down 6 will give me those 2 points. And that's how I got my second 2 points to get my shape. The y-intercept is also 0, 3. If I plug in 0 for x, I get 3 for y. And my axis of symmetry is just x equals the x coordinate of the vertex. X equals 0.